Okay, so I'm going to try narrating this thing. The sound didn't take, so at any rate, you're going to have a quiz next week on dissociation, dispersion, and electrolytes. And today we're going to be looking, oh, look at that, dispersion, dissociation, and electrolytes. Is this going backwards? So weird. Anyway, today we're going to be looking at ion concentrations. It's really quick and easy. And we'll also be looking at dilutions. So let's start with ion concentrations. We're just going to wait for me to write something. Oh, look, what does it say? Ion concentrations just involve stoichiometry, molarity, and you know how to do stoichiometry with molarity, so you're really set. It also involves dissociation, which again, you've just practiced the last week, so it should be okay. Here's an example. What is the concentration of sodium ion in an 0.30 molar solution of Na3PO4? What am I doing? I'm drawing a question mark. That was exciting. Now we have an 0.30 molar solution. That is the concentration of the Na3PO4. And we want to know the sodium ion concentration. Now this is an ionic compound, and what do ionic compounds do when we dissolve them in water? Excuse me. Excuse me again. This is going to be such a fun lesson to watch. Yeah, they dissolve, but they also do something else. Ionic compounds, when we put them in solution, yeah, they dissociate. They split apart into their ions. Dissociate. Keep using that word. You need to know it for next year. So let's write the dissociation of Na3PO4. And we're going to put our concentrations down below this dissociation equation. 0.30 molar is the concentration of the Na3PO4. Now, Na3PO4 is going to dissociate into how many sodiums? How many sodium ions are we going to get? We're going to get 3, that's right. So 3 Na pluses plus, and we have 1 PO4, 3 minus. Now, here we have a 1 to 3 to 1 ratio. So, our concentration of sodium, if we have a 1 to 3 to 1 ratio, what will the concentration of sodium be? Oh, and there's our concentration of sodium phosphate. If the concentration of sodium phosphate is 0.3, then if we have that 1 to 3 to 1 ratio, what is the concentration of the sodium ion? It's like watching paint dry, isn't it? Oh, we have a 1 to 3 to 1 ratio. Really? Nobody? Come on, you can do it. Look at that. 0.90, yes. So we have 0.90 because there's 3 times as much sodium as there is sodium phosphate, because it's a 3-to-1 ratio. And now what would the concentration of the phosphate ion be? Oh, 0.30. Yes, very good. Because it's a 1-to-1 ratio with the Na3PO4. And don't forget, the concentration is measured in molar. So, method number 1. This is how you can show your work, just like you did above there. You can write out the dissociation equation. And then you can show the concentrations below. Pretty straightforward, yeah? All right, let's do one more example. If I dissolve 32.0 grams of NaCl, except for I changed my mind, it's not going to be NaCl, it's going to be something else, in, oh, not 10. What am I going to put? 500 milliliters of water. No, see, I told you it wasn't going to be sodium chloride. Calcium nitrate. There we go. So if I dissolve 32 grams of calcium nitrate in 500 milliliters of water, what is the concentration of each ion? What do we need to know in order to solve this problem? Why on earth is this taking so long? What am I doing? This seems absolutely crazy. Are we just sitting around doing nothing? Oh, what am I doing? Oh, we're scrolling. Okay. Let's look back at our previous question. Dear God in heaven. Okay. Oh, there we go. What did we need to know from that question, the previous one, in order to solve for the ion concentration? Yeah, we needed to know the molarity of the solution. So let's go find that for this one. Oh, can I scroll back down? Apparently this is challenging. How can you guys stand to watch this? It drives me crazy. Anyway. Okay, so we want to find the concentration of the calcium nitrate. And remember, those square brackets mean I'm finding the molarity. So those square brackets mean molarity of calcium nitrate. And what is molarity measured in? Molarity is measured in, what are the units? Moles per liter. Yay! Yeah. So we want the moles of calcium nitrate per liter of solution. So we're going to put 32 grams of calcium nitrate on the top. Because we don't have moles yet, we'll convert it to moles. And on the bottom, we have our 500 milliliters, which becomes 0.5000 liters. And I think at this point, What just happened? My screen timed out. That's exciting. Okay. At this point, I think I went to go get a calculator because I needed to calculate the molar mass of calcium. So, calcium has a molar mass of 40.1. Oh, there we go. Nitrogen has a mass of 14. And so when I add all of those things together, oxygen, blah, 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 get 164 grams per mole. Okay. And I do the math on all of that. Our grams cancel out, and we're left with moles of calcium nitrate over liters. And I'm plugging that into the calculator, and we get 0.390, and our unit is the moles over liters. Or we could rewrite that as 0.390 molar. Oh, I think I was asking what else you could write that unit as. You can write it as molar. I just told you. Haha. Molar. Yay. Okay. Molar. So now we have the concentration of the entire substance, the CaNO3 Let's go find the concentration of the ions. And in order to do that, we're going to write our, what's that thing we call it when it splits apart? When it splits apart, when it dissolves, that is called they are aqueous, but I'm looking for another word here. Dissociation. They're going to dissociate. Yeah. Okay. So the ions are going to dissociate. Keep using that word. You should be really familiar with it by the time we're done this. Okay, so when it dissociates, we end up with 1 calcium and 2 nitrates. That's a weird looking 2. There we go. Don't forget the charges. Don't forget the aqueous. Okay. And we know the concentration of calcium nitrate, CaNO3 is 0.390 molar. What's the concentration of calcium ion, Ca2+, going to be? What's the concentration of the calcium 2+ going to be if the concentration of calcium nitrate is 0.390? 0.390, yeah! Because it's a 1-to-1 ratio. But we don't have a 1-to-1 ratio for the nitrate. We have a 1-to-2 ratio. And so our concentration there is going to be 2 times 0.390 molar. And so we get 0.780 molar. Yeah. Seriously, if you haven't sped the speed up on this thing, I would. It was going really slow. Whew. All right. So another way to show the work, this is method 2 of showing the work. Is we can just do some stoichiometry. We have why did I erase that? 0.390 molar calcium nitrate, 0.390 molar calcium nitrate. And we're going to use our mole ratio. There are 2 nitrates for every 1 calcium nitrate. Okay, do the math, you get 0.780 molar. Doesn't matter which way you show the math, as long as you feel happy about it, that's all that matters. And that is really it for ion concentration, which is why we're going to have another topic today, which is the dilutions. Remember, when you dilute something, you're making it less concentrated. How do we make something less concentrated? We're going to add water to a solution. Add water. Come on, you can do it. To a solution. Woo, excellent. Okay. So, for example, we have a beaker here, and this beaker contains 1 liter of solution, 1 liter. And in that beaker, we have these 2 little black dots, okay, and each of those dots, so if 1 dot represents 1 mole, then the concentration of the dots is, what's our concentration of dots if each of those dots represents 1 mole? It is 2 molar. Yes. Okay, so we have 2 moles per 1 liter, so it's going to be 2 moles per liter. Okay. Now we're going to add some water to this. We're going to dilute this solution by adding 1 liter of water, H2O. So here's our beaker, and we've added an extra liter of water, so now our total volume is 2 liters. But in there, the amount of solvent hasn't changed. All we've done is add water. There's no reason why there should be more or less solute. We still have those same 2 particles. Okay, so we still have 2 moles of the black dots. But our new concentration, we still have 2 moles, but now it's over 2 liters. It's 2 moles and 2 liters, which gives us a total concentration of 1 mole per liter. And you'll notice we doubled the volume, and the concentration became half what it was before. Cool, hey? Okay, the key thing here is that when you dilute, there is no change in the amount of solute. Okay, so the number of moles of solute remains the same. Okay. So, in dilution problems, step 1, because the moles of solute remain the same, your first step is to calculate the moles of solute. I don't know why I'm accenting the weird syllables. So, step 1, find the number of moles of solute. Step number 2, you're going to take those moles of solute and you're going to divide it by the new volume. So you're going to find the new concentration. And remember, concentration is just moles divided by volume. And your moles are the same as they were before. You're just going to use your new volume to find the new concentration. And that is it. That's it. Again, super easy. Let's do an example. Sorry, my screen keeps timing out. Okay, so we have, let's see, 2 liters of a 9 molar solution of sodium chloride is diluted to a final volume of, God, this is taking a long time, is diluted to a final volume of 6 liters. Find the new concentration of sodium chloride. All right, so step number 1, we're going to be finding the moles. So we're going to start with our old concentration of sodium chloride, which is 9 molar. That's our original concentration. And our old volume is going to be, of sodium chloride is, well, we started with 2 liters. So let's use that information to find the moles of sodium chloride. And if this is our beaker, here we have 2 liters, 9 molar, and we want to know how many moles are in that beaker. Okay, this is step 1, in case you didn't know. Here we go. Moles of NaCl equals, oh yeah, right. Remember, molar means 9 moles per liter. So we can use molarity as a conversion factor here. So we're going to take our 2 liters and we're going to use our 9 moles per liter as a conversion factor. 9 moles per liter. Our liters are going to cancel out, and we're left with 18 moles of NaCl. That's how much we have in that beaker that's right over there. And now we're going to proceed to add some water to it until we get to a volume of 6 liters, and we're going to use that new volume to find our new concentration. Ooh, that's ugly. Step 2. So the new concentration of sodium chloride is moles, of course, of NaCl, which is the same as before. All we've done is we've added water to those 18 moles of sodium chloride. The same as before. Same before and after dilution. So we got our 18 moles there. And concentration is, of course, moles divided by liters. And our new volume, because we want our new concentration, we're going to use our new volume. That, I believe, is our 6 liters. Do I have to scroll up and look it up? Maybe not. Let's see, 6 moles. 18 moles, sorry. That was in 2 liters. But now that those same 18 moles are in, oh, look, there we go, 6 liters. Excellent. Divided by 6 liters. And we get, nice easy math, 3 molar, or moles per liter. And that's a dilution problem. Just find your moles, and then find the concentration. Just use your new volume to find the new concentration. That's it. Let's try one that's a little more complicated, but hardly. Okay, we have 100 milliliters, 100.0 milliliters of water, and we're going to add it to 50 milliliters. You can do it. There you go. 50 milliliters of calcium hydroxide solution of a calcium hydroxide solution of concentration 6.1 molar. Okay, so same steps as before. Find your moles. What is the new concentration? Yeah, that's what it's going to say. Or what is the diluted concentration of calcium hydroxide? Find your moles. Moles will stay the same. Step number 1. Find the moles, just like I said, of solute. And that's going to be in our original solution. That's our old solution. So what do we know about our old solution? Well, we know that there was 50 milliliters of it. There it is. Yeah, there we go. So our old volume was 50 milliliters. And that 50 milliliters had a concentration of 6.1 molar. So our old concentration was 6.1 molar. Remember, that means moles per liter. Can we find moles using those numbers? Why, yes we can. Moles of calcium hydroxide equals, we'll take our 50 milliliters. Now we have to convert it into liters first. Oh, and don't forget, that means 6.1 moles per liter of calcium hydroxide. Oh, I forgot the little 2. No, I didn't. Molar. You. And 50 milliliters, we need to move our decimal place 1, 2, 3 places over to the left, which will give us a volume of 0.0500 liters. Now we can multiply by our moles per liter. 6.1 moles of calcium hydroxide per liter. Liters cancel out. And we get, now I've made a calculation error here. This should be 0.305 moles. Okay? I'm going to discover that later. So it should be 0.305, not 3.05. Step number 2, we have found the moles of calcium hydroxide. To find our new concentration, we just take our moles and divide it by the new volume. Find the new concentration using your new volume. So here we go, concentration of calcium hydroxide. New, that's our diluted concentration, is equal to 3.05 moles. No, it's not. It's 0.305 moles calcium hydroxide divided by, we're going to use our new volume here, moles over liters. We're going to use our new liters, new volume. Now, how much is our new volume? Let's go back to our question. And you can see that it says 100 milliliters of water is added to 50 milliliters. So we have to actually say our new volume is the combination of those two. So we have to do that addition ourselves. Okay, so our volume is 150 milliliters. Yay! And if anyone's good at math, you'll see that this is going to be a 2/3 dilution. Ha ha! And you'd just be able to go, oh, I can just multiply that by, oh, is it? Yeah, 2/3 dilution? Hang on. Concentration will be 1/3 of what it originally was. Yeah. Anyway, just ignore that. I just got bored. Okay, so we're going to put in our new volume here. 0.150 liters. equals 20.3. And this is where I realize I've done something wrong. I can't dilute it and have a bigger concentration. Oh no! Where did I go wrong? I must be plugging things into the calculator right now. Oh, it's not 3.05, it's 0.305. And let's go fix it in the other part. That's going to be 0.305. 0.305. And that's going to give us 2.03 molar. Huzzah! And we are done. Okay, that's it for this week. I'm sorry for the crummy video. My computer was doing strange things at work, and so you got whatever this piece of garbage was that I threw together by narrating over the video that didn't have sound. Next week, same time, noon on Monday. Your assignment should be online by now, and thank you for showing up if you showed up, and if you didn't show up, then thank you for checking out the video. Maybe you could even hit like. That would be very validating. If I got a few likes, that'd be awesome. Okay, take care, guys. Bye.
Thank you.